So let me start. And first of all, by thanking my team for the work I will present today. They contribute to most of it. And what we are doing, we focus our research on those quadratic materials that I will call sometimes also K2 materials. And we are mainly interested in investigating nonlinear and electro-optic signal at the nanoscale, developing multipolar imaging tools to study those nanomaterials, because the typical second harmonic generation microscope or multiphoton microscope, as it is called, they are really made for biology and not for studying devices or studying studying materials, let's say. And we have two ways of fabricating our samples, and really experimental and focusing on improving this kind of fabrication by using some unconventional, let's say, assemblies of materials for making out of nanomaterial micromaterials, as well as typical top-down fabrication that you will see in any clean rooms. And this is the goal here, to master those fabrication that seems obvious with silicon or 3,5 material, but when you go to those oxides or metal oxides, the fabrications start to be a bit tricky, especially the etching process, top-down etching processes. So what are quadratic or K2 materials? So they are non-centrosymmetric material, contrary to silicon and diamond that are centrosymmetric. So for instance, even crystalline quartz, gallium arsenide, and the two main materials I will talk about today, barium titanate and lithium niobate, are non-centrosymmetric. They are well known as bulk. I'm not saying here I'm using a new materials, because they are used since the 60s or 70s. But as thin films, so when I mean thin films, is films that are below 1 micron in sizes, or as powder, they are much less known, at least in photonics. Barium titanate, though, is known, right, as powder. This material is produced by kilos to make condensator, actually. But for photonics, this is much less well known, and there are quite some studies since the beginning of 2000 to make lithium niobate thin films, let's say the equivalent of SOI, but in lithium niobate on insulator with a 2 to 5 micron oxide layer, and at the bottom also a silicon wafer, and also in lithium niobate and barium titanate synthesis, as well as assemblies of those particles to make photonic devices. And why making photonic devices and miniaturizing them with those